Alrighty, well, hey, thanks so much for tuning in. Anyone stumbling across this video here, but I am excited and interested to chat with these folks on a new vulnerability that's been kind of introduced and remediated. But before we get the ball rolling, I would like to let these gentlemen introduce themselves. So Simon, can I kick it off to you? Who are you, my friend?
Absolutely. So I'm Simon, one of the co-founders of Confio. My background is software development. I work on CosmWasm development for the last 2 years. CosmWasm is a smart contracting engine for the Cosmos. Yeah, I'm doing that. I'm the managing director of Confio. And yeah, a little bit of software, a little bit of management.
Awesome. Steven, hey, I want to give you the opportunity to introduce you and your team.
For sure. So I'm Steven Walbroehl, one of the co-founders for Halborn. Halborn is a blockchain enterprise end-to-end security firm. We have a team of almost 80 engineers now, and Luis is with me here on one of them. So glad to be here, John. Thanks for having us.
Luis, tell me about yourself, my friend.
Hey guys. Well, I'm Luis Quispe Gonzales. I have been involved in offensive security for around 12 years. Now I'm leading the CosmWasm-security team at Halborn.
Awesome. Well, hey, thank you so much, everyone. I'm excited to get this group together and just chat a little bit. But Luis, I think you might be the one kind of setting the stage for the story here. From what I understand, you uncovered an interesting gimmick, a little flaw, a little bug, a vulnerability. Do you mind telling me about what you discovered?
Yeah, sure. I will try to do a quick and a not so technical summary of what the vulnerability is about. So if we start from the basics and we talk about addresses, in general sense, the addresses, I mean general sense because it can vary from one blockchain to another, but it represents a user or a smart contract in a blockchain. It's like an alias. So does it mean that any user can create any address with whatever combination of letter or numbers? I don't know, like Porky 001, not so fast. Depending on the blockchain you are dealing with, the format you use will be different. So, for example, in Ethereum, talking about Ethereum, they use hexadecimal format. So all the addresses has 42 hexadecimal characters. That's Ethereum. On the other hand, if we talk about blockchains that are built upon Cosmos SDK, they use a format called beg32. And what's that? It's a format that has 3 parts. The first part, it's called a human readable format. And basically, it's just a string that identifies a blockchain. For example, if we talk about Terra, the human readable part, it's called Terra. In secret network, it's called secret, and so on. A second component is the separator, that in this format, it's always the number 1. And the final part, it's called the data part, that is at least 6 characters long, and it's a combination of alphanumeric characters. We only exclude 4 characters. There are the 1, the B, the I, and the O. At the end, we have 32 characters to play with. That's the Y of the name. So what is really interesting is that the beg32 format specifies that the addresses can be all lowercase or uppercase, but not a mix. So what did we find here? Cosmos SDK change that used CosmWasm as a smart contracted platform did not normalize the address. What does it mean? That when you verify an address in CosmWasm, the lowercase version and the uppercase version are treated as different addresses. And if you consider this issue and the fact that many developers are not aware of all this stuff about lowercase, uppercase version, it creates a scenario where an attacker can completely bypass validity checks in the contracts under certain conditions. In fact, we identify this vulnerability in different DeFi protocols that now are patched, of course.
I would like to support like that last point. Developers are not aware of that. I am working in this technology and building on this technology and looking into the specifications and writing implementation in both JavaScript and Rust for 2-3 years now, and I was not aware of that. So this is really something that only exists because it allows you to efficiently encode addresses in QR codes. And this is why it was included in the specification. It's nowhere out there in the real world. Nobody has ever seen this, but it's legal and proper implementations accept both forms. So, yeah.
Well, thanks, Simon. I'm glad that you were kind of chiming in there, because I did want to turn it over to both you and Steven, because I realize and I understand, hey, with discussion of vulnerability, with discussion of this thing, it's a bit, hey, fragile and sensitive. So I'd more than happy to let you kind of color the picture in here. What is CosmWasm and Cosmos and all this, and why is this vulnerability so important to address, and what are the odds and ends of it that we might not be thinking of?
Yeah, I can start really quick, and then Simon's the expert with the language for sure. Yeah, he gets big deals. But what, finding things like this, an example of what could happen is you can like bypass validity checks. You could duplicate liquidity pools. You could permanently lock tokens with this if you exploit it. So the impact is very, very severe if it is exploited. And the blockchain is something where people lock their funds on there. So there could be millions, potentially billions at stake sometimes. So this is a big risk. And CosmWasm is one of the languages that supports and is built on all this. So Simon can explain a little bit about the language.
So yeah, I can explain a little bit about the module system of Cosmos in general. So Cosmos is, or Cosmos SDK to be specific, is a framework to build layer 1 blockchains. So every blockchain that is built on Cosmos SDK is running completely independent, but they share a set of basic components, off-the-shelf components, things like governance or basic tokens. You don't want to re-implement that for every blockchain that you use. And also, you don't want to build your own clients for every blockchain that you create. So it's gotten kind of handy to share common functionality between different blockchains. But it's still modular. You can choose what you want to have. You can add your own things. You can also customize the things that exist, because they are kind of what you want, but not exactly. And one of the modules that Confio created for the Cosmos SDK, we are not the creators of Cosmos SDK, but we are the creators of one particular module for the Cosmos SDK, and that is CosmWasm, or XWasm in Go speak. And that allows you to add a smart contracting virtual machine to your chain that allows you to dynamically run code that is uploaded either by arbitrary users in a permissionless way, like we are seeing on Juno or Terra or Secret Network, or you can use it in a permissioned way where only governance is allowed to upload smart contracts. This is something that we are seeing in Stargaze and Osmosis, for example. Even there with this module that we provide, it's still very easy to configure it in the way that you want it to be configured. And yeah, usually in Cosmos SDK, people decode their back32 addresses to raw bytes. And as soon as you do that, you don't mind which printable representation was used before. Because if it's uppercase, lowercase, it doesn't matter, they all contain the same data. This is how the specification was written. But then for writing smart contracts, we wanted to make it a little bit easier and a little bit more convenient and a little bit more user-friendly, developer-friendly, easy to print, easy to debug. Yeah, you know this stuff. And we took a little bit of a shortcut, which was then creating the issue. We basically encouraged the user to say, yeah, you can use this printable representation straight away. You don't have to convert it to the raw bytes. And this is something that was not the way the specification intended to, and we got bite by that. Because yeah, there are obviously two different representations of the same address, which we were not aware of. And this is something that is particularly an issue in CosmWasm smart contracting. Some of the smart contracts, not all of them, if you convert them to raw bytes, which you can, you don't have this issue at all. We don't see that in Cosmos SDK development because there you always work with addresses based on raw bytes. You always decode the address when you get it in, and you encoded it when you get it out. But for all the computations, it's always used in raw bytes representation. So it's really something that is happening on the CosmWasm stack. It's our fault, completely our fault, because we did not see this in the specification. But we found a good way to fix it now.
And there's for those maybe unfamiliar with blockchain, there's I think 20 different blockchains deployed out that are using CosmWasm underneath it, and other variations of it. Solidity is a really popular one for like Ethereum. That's the language that you code smart contracts in. And there's also some blockchains that use something called Substrate, like Polkadot. There's Haskell is used for like Cardano. So CosmWasm is one of those that's providing a mix of the Cosmos SDK for it's kind of like the network consensus layer, and then the WASM, which is WebAssembly, which is in Rust and usually runs the programs and contracts on top of that. So it's a mix for it. So this is that particular chain here. One's like Terra, which is probably the most popular and the largest that people have heard.
Can I ask, Simon, what were kind of the steps taken to go ahead and fix that? I mean, from my understanding, hey, it's the differentiation between lowercase and uppercase. Do you just force lowercase? Do you take some better normalization and validation in that address verify function? Or what did you do to fix this here?
So when we received this report from Halborn, we really thought about, okay, at which level of the stack do we have to fix this? Because obviously you could blame the contract developers and said, yeah, you have to convert this to raw bytes, it's your problem. However, we encourage them to use the printable representation, so it's also kind of our problem. And also, we don't want to leave everybody out there with deployed smart contracts in a very dangerous situation with this. So the question was, can we find a way to fix this on the chain in a way that once it's patched on the chain, it's the patch is available to all smart contracts, the ones that are already deployed as well as the ones that are newly deployed. So we thought about that and realized, okay, we have address validation, and it's not super clearly defined when an address is considered valid. So since this is not clearly defined, we thought, okay, we have a little bit of freedom here. We can say, okay, afterwards we define that more strictly than we did when we originally created the function. And we said, okay, this does not only, an address that we get in does not only need to be valid back 32, but it also needs, in addition to that, needs to be normalized. And normalized means when you decode it and encode it again, you get the same value. And that means in practice that it has to be lowercase, because lowercase is the primary representation, that one that you get when you create a new back32 address. There's another aspect that makes this a little bit tricky, which is that the CosmWasm stack does not know which address format the chain uses. So it's completely transparent for the virtual machine what the format is. It just says here, chain, please verify this address for me. So it would be very well possible to deploy CosmWasm on a blockchain that does not use back32, but use hex, for example. And there we have the same situation. If you have the address format that is popular in Ethereum, there can be mixed case representations of the same address. And the fix that we found then, after carefully considering the options, was one that not only works for back32, but also works for hex and DID and whatever address formats people are already brainstorming for the future.
Cool. I'm going to momentarily break the fourth wall. I don't know if there's more that you all would like to chat about. Am I forgetting anything, or hey, should we just start to ask, do you have any last closing thoughts, words of advice? I absolutely want to hit Luis one more time and say, hey, from your perspective as the security researcher, how likely is it to see other vulnerabilities like this down the line, other things that other developers might need to know throughout more security cases like this? Is there anything else that we want to talk about, folks? Because again,
yeah,
hey, this
really
is
quick. Yeah, I could talk about just in general, Halborn and security researchers like Luis,
yes,
when we find these issues, it's very sensitive. Just in general for security, finding these 0 days can be a bit of a tricky subject of maintaining secrecy while getting fixed to make sure that it's not exploited for that time in between. It's unique with blockchain aspects because things happen so fast. If a vulnerability like this is found, or something like on Ethereum, a Solidity 0 day, people can anonymously go and on chain and start liquidating funds, or leveraging the exploit to steal or lock funds out of there. So it happens extremely fast. So there has to be a lot of care involved with that, and make sure that notification is done to the projects that may be impacted, and patches are put out there too. So that's one thing that we try to take care of, and work with all the individuals that are impacted to make sure that everybody's funds are protected here, and we get the patch out there. So great job working with Confio, and Simon, your team was very, very cooperative. It was a pleasure going through and helping the community with this fix.
I'm aware, hey, there was a patch released on the 6th of April. Is that right? How are you feeling, Simon?
6th of April. I know it was Wednesday last week. But yeah, in addition to that, in this particular case, it's even more tricky because CosmWasm is an open source framework. So the moment we release a patch does not mean it is shipped to the end user. It is shipped to the project that built on top of our software stack. So at that moment, it's really up to the chains that use our software to react quickly. And we have security communication lines with a lot of major chains, but to be honest, we don't know who our users are. We know a handful of them, but it's open source. Everybody can use it. I don't know who's using what version of CosmWasm. It's already so many users, we can't keep track of all of them anymore.
And it's usually like in traditional security, like the Windows patches come out, and all the security researchers and hackers start diffing between the different patches, find out what did they change, what did they change, is it because of a vulnerability, and then see how they can reverse engineer that to exploit it. Same thing happens here.
Yeah, even worse. I mean, the patch is open source. It's not that you have to reverse engineer anything. You just have to understand the patch.
Yep, the logic. Yeah, find the logic what it's doing.
Yeah, and I would like to highlight an important aspect, and it's that the patch is out there. You can use it, but of course, the key part is that you have to use it. It's like having a super anti-cross-site scripting library that can do whatever. But if the developer does not use that library, at the end, the input-output on a web page can create a cross-site scripting situation. It's the same here. If the developer doesn't validate the function with the address, I mean, if he doesn't validate the address with a address validate function, at the end, it will happen again. And that's why it's important to the awareness for the developers about what are the key issues in the actually in the blockchain world, in this particular case in the CosmWasm contracting platform. So just to highlight what are those key aspects they should focus to not create bugs in the smart contract.
Absolutely. So education is key. We are working on improving the documentation. We are launching CosmWasm Academy later this year as Confio, which is a training program that guides newcomers through the basics of CosmWasm. And we'll make sure to get a lot of well-educated CosmWasm smart contract developers out there who avoid the basic mistakes.
We can share some of the possible consequences that can happen because of this issue. For example, we are talking about bypass validity check. What does it means? What is the effect in the defined world? For example, you can imagine a scenario where you try, in the logic of the contract, you try to validate if in a particular address should be different to another one to continue the processing, to another one or to a set of address. So this kind of validity checks can be completely bypassed by just using the uppercase version of the address, and you can start continue processing. and it will work because at the end you can use those addresses as valid ones. And what are the effects in this kind of scenarios? We have seen, for example, it can affect the funds in a contract. It can affect the reward distribution. It can affect the vesting schedule for different protocols. Another case we saw, it's about the liquidity pools. If, for example, we talk about the automated market maker, one key aspect here is to have a high liquidity pool. So here I have two cases, but what is the key idea behind that? For example, that's a code that we have seen on the wheel in the DeFi protocol. So for example, here you see that in this part of code, in a liquidity pool, in this case in an AMM, you try to verify if a pool for a particular pair of tokens exists or not. If it exists, you don't allow to create another liquidity pool for that pair of tokens. And that's important because for those kind of protocol, if you fragment the liquidity, that's bad for the protocol, that's bad for the user, it increases the fees, and it's not working, it's not good. So in this case, if you see, here you have the key for the pairs. And if you see that the code of this function, you see that at the end, you turn the information about the asset that at the end, if you see here, it's just an address, you turn this into bytes. And this function tries to verify if a specific pair exists or not. So if you create a pair with a token with a contract address that it's in uppercase, you can create a repeated pool, and you can do it until 4 times. At the end, you have 4 liquidity pools, and again, you fragment the liquidity for the AMM protocol, and it creates that unexpected situation. Some consequences: a reduction of pool liquidity, that is key, as I mentioned, and in some scenarios, it even helps attackers to bypass other restrictions to withdraw more tokens than they should. That's obviously, again, bad for the protocol. Another example for money market, for example, here you try to execute a swap, a specific asset to USD. So if you see the code here, it contains an address. And if we see the implementation, you see that you are comparing the input contract address again and a specific one. And so if you can bypass this restriction by using an uppercase version of the address. Consequences: an attacker can swap all or almost all tokens, and legitimate user won't be able to unstake their tokens, or will receive in return much less than expected.
From my side, it has been clear that, it's been another incident that shows that blockchains really need to think about their security patch policies. We have seen groups discussing putting out community proposals to upgrade software and this kind of stuff in a situation where you should have acted yesterday and can't afford to put out a community proposal to vote on a software upgrade for 1 or 2 weeks. This is not a software development problem. This is not Confio's problem, but this is something that the ecosystem has not answered.
Yep. Yeah, there's some ecosystem problems just in the way blockchain works, and some of the community where, if you have an operating system like a Windows update, you'll get those notifications to patch it. But sometimes it's your responsibility, just like Bitcoin, where you become the bank and you're responsible for holding your funds and your key. You're responsible to manage your nodes sometimes, to update your validators sets and chain for it. And so yeah, if you're involved with this, or an ecosystem contributor, or somebody in a DAO, then you have some responsibility of security that you have to take seriously and be a bit more proactive.
Yeah, as you know, security in the blockchain world is relatively new comparing for, let's say, traditional technologies like the web world or the mobile world. So we are working, actually, we research about these topics. We try to create always top 10, a top 10 of common issues that affects the blockchain world in different flavors here in CosmWasm, but for different blockchain. And our idea is to share this info with the community too, so developers are aware of this kind of issues that could happen if they don't take into consideration in the development of these smart contracts.
Alrighty. Well, hey, thank you so much, all. This was enlightening. I think it's fascinating for me to see, and I hope for others listening in, that whole world of security, even applied to that blockchain and Web3 ecosystem. It's something that we do have to take seriously, each and every one of us, and it's a burden to bear from every perspective, developer, user, etc. Thanks so much for shedding some light on this, everyone.
Thanks, John.
Thank you.
Thanks, guys.